Okay, one moment. 1 second. I'm about to start, but wait a moment. 1 second. And. Okay, we've begun. So if you're watching this video on demand, which means you're watching this after the fact, skip a few minutes ahead because this exists live in a live stream. So that means I take a few minutes to set up, make sure everything's working, but you don't need to see that. We're going to do day 11, which is Hive, but the people here don't know that yet. So you're special. Skip a few minutes ahead, and I will see you, talk to you in a bit. Okay, as for the people that are watching this live, like Peace Among Us, for example, I need to hear, or I need to know that you hear me and you see me and everything's in sync because I don't start until then, even though I already know I'm in sync and I've always been in sync. So if you're watching, you have a responsibility to tell me, and then we can get started. Waiting for it. Waiting for it on the edge of my seat. Never have I not come through. So here we go. Okay, all good. Amazing. So today is day 11 of Nodevember. I know it's November 10th, but I do it ahead of time by a day, especially later on this month with Thanksgiving. I want to get a few days ahead. But yeah, today's day 11. And before I get into that, yesterday we did day 10 if you were on the live stream, which was later than it usually is because I didn't want to do it in the morning. We did zipper, and here's what the render turned out to be. So the concept was take two strands, make them go into a zipper, but then they loop back. So you have one zipper that connects them and one that splits them. So it's kind of this like infinite's probably the best word, Ouroboros kind of situation. So came out pretty well. If you want the project file for that one, go to cgmatter.com. That'll take you here. Member site, if you're a member, go here for Nodevember, and you're going to see all of these, including day 10 zipper. When you click it, it's going to download, or you could watch the stream if you missed it. So once we're done with day 11, I'll also post it here. And additionally, only thing I'll say is I'm going to be using some free nodes in this live stream. Somebody asked, do you need to be a member? No, these are free. Go to free nodes. And then in here, you can install the add-on that will let you get the nodes. And the reason that it's an add-on is so that it can be refreshed without you re-downloading anything. Okay, so with that, let's begin. So Nodevember day 11 is, we're on the third block now. It's Hive. Obvious thing that comes to mind is bees, specifically a beehive, and I am going to lean into it. I know it's basic, but I want to do it well, which I don't know if anybody's going to do. It's kind of similar to drone if you end up making bees. Hive, what I'm thinking is we have some kind of beehive, which means we have this hexagonal pattern, maybe with wax and maybe with honey dripping off of it. And then the complicated part is I want to have bees walking along the surface of it without intersecting. So they move, they walk, but they don't go through each other. That's going to be the complicated part. I brought in some photo reference. So this is like the very simple version of a bee I'm going to make. It's not going to be detailed because ideally it's not very close to the camera. The legs are just going to go up and down and the wings are going to flutter and the bee is going to walk oriented tangent to the direction it's going. And here's a good example of what I'm trying to do. Something like this, except they're walking over it, and I might make the hive bigger so that you don't see the individual bees. Here's some more reference of them walking over. Here's a reference of me covered in bees, which vaguely is the idea I'm going for. You can't really make out any individual bee until you zoom in here. And what's this one? This one's a GIF of maybe how they walk. So interestingly, it's not like they're walking a lot. It's more like they're reorienting all the time. Okay? So that's the goal. Let's get into it. Tomorrow, Blender 5.0 comes out, but today it doesn't. So I'm just going to use my 5.0 beta. And I'm excited for 5.0 to come out, because then I can get rid of my old versions and not have these portable folders. I'm nervous because I use Serpens. I use an add-on to make an add-on called Serpens, which I believe is not 5.0 compatible yet, although the person's working on it. And do I need glasses? No, we're close enough. And it's foggy. Okay, how are we going to do this? Well, I'm going to save this project as day 11. Day 11 is Nodevember. Day 11, which is Hive. And by the way, recently, I used this little, I don't know if you can see it. I used this little dongle here to connect my wireless mouse, and before it was under the table, which is why it was stuttering. But now it shouldn't stutter. Okay, what is a beehive except a bunch of hexagons that we wrap around a shape? Well, before I try to make like procedural hexagons, which might be a bit of a pain, or at least to tile them, I did have an idea. I don't remember if it works or not. So here's what I'm thinking. I'm going to start off with a grid, let's say a somewhat dense grid, and I want to turn this tiling of squares into a tiling of hexagons, okay? Or is it octagons? I'm pretty sure it's a hexagon. Let's see. Yeah, it's a hexagon. So my idea was, and now that I'm thinking about it, I don't think it is going to work, was I was going to run a dual mesh node. That isn't working. So that totally doesn't work. My idea was, I thought a dual mesh would take a face like this, look at its connected neighbors, which I guess is 8 of them, and somehow combine them. But that doesn't seem to be how it works. So what if I triangulate this? I triangulate this, and then I run a dual mesh. What does that get me? Oh? And they said I wasn't a genius. There we go. So that's a quick way to get hexagons. Of course, they're askew. But I can fix that maybe. See if any of these do anything. Okay, that's fine. So here we have a hexagonal pattern. The reason this works is once this is a triangle, if I look at this one, it has 1, 2, 3, 4, 5. If you look at the corners, 6 neighbors. So vaguely, that works for a reason. That's fine. So now we have our dual mesh. I will need to kind of make this askew, but for now, let's make this a bigger pattern with twice as much, and then we're going to wrap it on a surface. Okay, how do I intend to do this? Well, clearly, we need to skew this to go on the x-axis to the left. A simple set position job where I control the x component, and it should be it's not as easy as doing it like this. We should skew it as we go up the y-axis. So I'm going to use my generated coordinates node. To get my nodes, just go to cgmatter.com, go to free nodes. You don't need to be a member. You can just pick those up. So as we go up the y-axis, we should skew the x. And that seemed to do it, actually. Okay. And then I want more of these. I guess another thing I could have done instead of this is play with the size of the x, or the y, the number of vertices. Well, we have an easy solution, so I'm happy with that. Additionally, I would like to make a copy so that I kind of fill this out into a grid, or like a big rectangle, and then I can take that and wrap it around. So how do I want to do this? I basically need to see the total length of this, which isn't that hard because I know the size is 2 meters, and then instance it that way. So maybe we could just run a transform, join these together, and move this 2 units on the x, which is vaguely incorrect for some reason. Okay. If I wanted the exact number what I could do is I could measure this distance, but from here. So I only look at these points and then I check how like wide are they. Yeah, I think that'd be nice. Okay. So I'm going to look at these generated coordinates now over here, and I want to look at where the y is equal to 0. In other words, this bottom selection. This I want to separate so that I can view what I'm dealing with. So this is almost what we want, but we want one more above. So let's see if I make this edges. No. I'm going to take the points, I'm going to blur them so that they go up an iteration. Okay, and now if we can get the width of that, we are golden. Great. So a way to think about this is I need the range. So I have a field range node for this. And we need to know the range of the x position, right? So I'm going to run my separate position node. Again, all this on cgmatter.com. This will tell me the range of this. Yes, okay. So I'm going to sample on index this range, which is going to be the same for any index, so it doesn't matter what it is. And then all of this, which I'll clean up in a moment, I want to make a copy of. I want to transform it and then join it together such that this x offset is this number, I believe. No, because now we have the same issue. I don't want to blur it. There we go. So just with that, we have the exact spacing we need to create a wrapping. Okay, so how did we do this? We had a grid, we triangulated it, and we dual meshed. That made the initial pattern. I then did this set position trick to get it to be more the correct shape. And I guess we more so just got lucky that this is vaguely correct. But that's fine with me because we're going to tessellate this. So all of this I can call our hexagon pattern. And if you just hopped on, we're making a beehive with bees on it for day 11, which is Hive. Let me just bring up a reference actually, so that people know as they stream in. Something like that, okay? That's what I'm going for. So I need this pattern to repeat. So we did all of this math over here. And what this math gets us overall it gets us the spacing for the x. It knows the exact width of this that I translate by. So before, I was just picking a random number and joining them together, but now I know the exact coordinate. And additionally, I can do as many iterations of this as I want, because now I can do a mesh line where the spacing of the line is this. Okay, so now if I look at this, we get a long line. If I do 2 points, this should be exactly the width of the hexagon pattern. And then on this, I instance our hexagon pattern. Boom. So that should be exact. And then as I bring it up, we can increase that. And really all I need is just enough to wrap it around. So I don't even know how many iterations I need. Either way, this whole section is just about finding that spacing. So we can call this like pattern bounds or something like that. Or maybe like pattern x range, and that vector is going to represent the X range, taking in the hive or the pattern just like that. Okay. So now we have a nice procedure way to instance this, and I'm going to realize this. Note that when I do that, this overlap, you can see it right there, if that comes through on the stream. That needs to be merged by distance because technically they're just overlapping, so I need to connect them. And now we got this. Okay. And I'm going to expose a integer that tells me the count for our instances. Okay, great. So now the question is, how do I wrap this onto a shape like this? Or even the question is, why did I even do that? Let me think for a second. If I do a cylinder that I add segments to till it's roughly equally spaced, I triangulate, and then I dual mesh. That kind of gives us what we want. So you can see these hexagons, but they're weirdly distributed. So I guess that's why we wanted control, to get that exact ratio. Either way, that is a strategy, just so you know. So what I'm going to do is I want to wrap this so that this end and this end are kind of glued together, if that makes any sense. And that's kind of the same bending issue that I was talking about with something. I forget what it was we were making that required that idea. What was it? Oh, it was the crown where we made one segment and then we radially wrapped it. Actually, here you can see that breakdown. We made one component and then we instanced it and wrapped it. So it's actually a pretty similar idea. And these ends should connect nicely, I believe. Okay, so to make this visually simple, I'm going to transform this so it's rotated 90 degrees on the x. So now we just need to wrap it around the z-axis. And I'm going to use that sine cosine trick that I was talking about before, where to get this into a circle, I just need to look at this field, the length of it, and as we go along it, it's going to do one rotation. So in other words, I'm going to set position. The x and y coordinates are going to be determined by sines and cosines. So x gets a cosine, y gets a sine. And at some point, I really ought to make that a node group. And then the z component is going to be its original. So it's going to keep z, but x and y, this wrapping in a circle, are going to be dependent on sine and cosine. Well, we want to do this as we go along here. So it might just be as easy as taking our generated coordinates along the x, that goes 0 to 1. We multiply by 2 times pi, because that is one period, one wrapping of a sine and cosine. And that should be the position, not the offset. Okay? So you can see it's wrapping with a bit of a gap, which I think I know why. But also the z component, which I'll use my separate node, should be maintained. Okay? So you can see the only issue here is, again, we have this situation here where the total length of this in terms of a bounding box isn't really reflective of what we want. We just want the length from corner to corner. Well, we know one of these, right? That's what we did right here. We got this x length, and then we just multiplied it by 4. So if I separate this only into its x component and then I multiply by something like 4, This should give us the full length of it. And then what? Then we go from 0 to the length and normalize that 0 to 1? Yeah. I think so. Give me a second to think about this. So that is the length. I go 0 to 1. But then I subtract the thing. Might be as simple as a map range. Let's see. So I'm going to separate my x, y, z so that I look as we go along the x from 0 to this. I believe that is wrong, but let's just see what this gives us. Okay. So here you can see the connection points kind of whack, but there is something we can do to get this correct. Well, we know the length it needs to be. We could just do a field from let's see. I could do a field where I take the x coordinate. Remember, we're looking at this. I'm going to take minimum, so this left value over here, as low of x it can be. And then instead of taking the maximum, which is actually over here, but I want this corner, I'm going to take the minimum, and then I'm going to add this number. So we know we start here, and then we add this length. Okay? So that's our minimum and maximum. We then take our x coordinate and map it from minimum to maximum, sent to 0 to 1 of that. What does that give us? Kind of gives us the same thing. Almost makes me think that this number is wrong. Okay, so that's the length of it. I multiplied by 4. What happens if I increase or decrease by 1? Interesting. It's almost like it refuses to connect in a way. Why don't we reskew it with matrix node? Dual mesh sort of creates a new vertex at center. Yeah. These are some good insights. But it's not the problem I'm cooking on. So minimum to minimum plus maximum. Like, it shouldn't just be this. But instead, we should add some contribution. Subtract some contribution? Why does it not want to work? Well, we like a good problem, so let's think about it. So we take the lowest that the x can be. That's one endpoint. And then we look at the biggest x can z, or not the biggest, actually, this corner. We know goes from here to here, where we know the length of one iteration. And we multiply it by however many iterations we do. So now the maximum is going to be minimum plus that. We then map range our x position to go from here to here, and we normalize it. We do our sine cosine. Interesting. That doesn't seem to work until we make it really big. Like we take the limit of it. It's almost like I need more wrapping. Like here, I just pick the numbers that seem to work. But I don't like that it felt effectively random. So I guess the way to think about it is we have this. If I was to wrap from here to here, 0 to 1, and I do it 0 to 2 pi, it's not going to be perfect because there's going to be that gap, right? There's going to be that gap where if I just use the normalized coordinates, I get this. So there's a bit of a gap. So the question is, how much extra do I need to wrap it? So maybe we do this kind of after the fact. So we need to wrap it extra by the relative difference between them. So the relative difference between this whole length and then this other length. I'm going to try that. I don't know if it's a multiplicative or an additive kind of situation here. But let's see. I'm just going to experiment. So I'm going to take the total length like that. Okay, so that's the length from corner to corner. And then I want the length that isn't correct. So I'm going to use my field range node. And let's make it by 4. I'm going to use my field range node. This is going to be bigger than the original length. So let's say it's like 1.3 times bigger. I then multiply it by this number. Definitely not. And why do I not multiply by that number? That makes it smaller. Oh, wait. I see the issue. Whatever this is, I multiply by 2 times pi. Okay, did that correct it? So let me make this 2 times pi so I can look at the difference. So we have this, we have that. The only thing I'm not sure is, was there overlap, and it just looks correct. Well, what I can do is I can mix this from this to 2 times pi. So this is 2 times pi, and boom. We mathed it. We did the math. Great. So I basically got the ratio of the length it thought it was to the real length. I took that ratio and I said spin it by that extra ratio. Complicated to me. So it's kind of hard to explain. But that seemed to do the trick. Great. So let's take this over here. What's this? This is the x value of that. I divide. Great. I take that and I multiply by 2 times pi, which I guess also will never change. So I'm going to throw it onto that stack. And that is a scaling factor for our wrapping that gets signed and cosigned, and then we keep the z component. Great. Great, great, great. So generated x. Okay, great. And I'll make this a node group in just a moment. The only other thing is if these are a bit stretched, we can easily remedy that now by taking the z component that it keeps and just kind of scaling or shrinking or whatever. And we can figure that part out, but for now I'm pretty happy with this. So we have our hexagon pattern. We find that x range, that magic number. And we get that mesh line so we can instance. Okay. So this part, why did we transform? To make it vertical. So this part, I believe I'm happy making a node group. So this can be our pattern instancing, where we do it by some number. In this case, the count is going to be 4. So this is our count. Our offset is, what is our offset? Our offset is the x range. In other words, the length. The instance is the instance. And yeah, that's great. And then this section right here, all of this can be considered our wrapping logic. This should really, really be a node group at some point. One day. So this is going to be our wrapping logic, where the count is going to be the same. This one should be a integer because it always is that. So I can call this the count. Great. And let's put the x range at the top for cleanliness. Okay. That is about as neat as we can get it. Now, in theory, whatever number I pick for this, it should find the best wrapping, which might mean it's stretched, but there you go. Great. So we kind of have a density slider, and it turns out when we pick 3, we're pretty good to go. So now we have a cylinder of hexagons. Okay? Now, again, you might wonder. You might wonder correctly, and I wonder, why did we not do a cylinder? Where that cylinder had some side segments. We want none for the fill type, which basically means that it has no top and bottom. We take a triangulate node. We take a dual mesh node. And then we have our hexagon pattern. Well, it really is the skewing that seems hard to get rid of. So we could approximate it, but that is something that would be an issue. And now that we have this and we can, you know, customize it, I want to turn it into this nice beehive, which basically means I need to pinch the top and the bottom. Okay. How do I want to do that? Hello, Blunder Einstein. Well, hello to you. Okay. So now I want to do that pinching thing, which, unless I think of another idea, is as simple as set position. Ooh, I wonder, could we do a scale elements? So scale elements does this, and it's important to realize these are faces, which I guess is quite useful. Weird. They are faces. So I want to scale elements such that it only goes on the x and y. So I wonder, yeah, I can scale it on the x, and I can scale it on the y. And then what do I want to scale by? Well, I'm going to combine x, y, z. No. I'm going to make this a number, and as long as that number is the same, it's like an xy scaling. Okay? That number, of course, is going to be dependent on how high are we on the z-axis. We're so high. So I'm going to take the generated coordinates for the z, cgmatter.com, for that node for free. I'm going to remap it using a float curve. So here we have kind of a, how do I want to treat this? Not What's going on here? We take the generated z, we go from 0 to 1. That should pinch the bottom. Because if we scale by 0, we get that. So that's what's giving me pause here. Let's take all of that off to the side. So generated coordinates should go from 0 to 1. Did I plug this in the wrong spot? No. Nor is it looking at this. I wonder if this is a geometry issue. No, no instances, nothing like that. Why would that be the case? The generated coordinates go from 0 to 1. Interesting. I wonder if it has something to do with the order of operations. So let me capture this attribute. No. Weird. Weird. I don't know why that is. Right? Does the scale not actually take in a field? Is almost what I'm seeing from this. What if I set this to edge? No. I am either forgetting something, and if I am, comment it, or I am finding a bug. I assume I'm just not thinking about something. Did anybody say what it is? If anybody can figure out what that is, that'd be good to know. Either way, I should be able to do this custom where I set position such that I take the position and multiply by a custom thing. I don't want to change the height. So now this is kind of acting the same way. I output this, I output that. So this is what I expected to happen. I don't know what happened elsewhere. So I'm going to set the scale to 0 everywhere, kind of have some curvature here. So now you can see how I'm hoping to get this beehive. And we need to kind of skew the shape so it's kind of flat-ish on the bottom. That looks pretty good. And note that if we have this, we're going to have a infinitely thin point at the tip, which is fine. We just got to remember to merge that. And to not make it too harsh, otherwise we get something like this. Yeah, you see how harsh that is? It's kind of hard to show. Like one strategy is we can just not show the bottom. The other strategy is to make it really smooth. It doesn't like that. It doesn't like that because originally they started off quite far away. So I would imagine, I don't know if it matters if I transform this on the XY. I'm going to do something like that. Another issue is these are n-gons. If I triangulate it, it should be a little nicer visually. But I do want to keep those hexagons. Weird. Well, not weird. That's expected behavior. Okay. Well, given that, what we might want to do is add resolution, right? So that's the advantage of what we did here. We can always add resolution. And that should still, I still want it to be soft on the bottom. So it should have more time to grow, like a lot more time. No. I think it will inevitably stretch the bottom, unless if we were to kind of rework the logic here. I think I might just go with hiding the camera angle. And then the issue is we also have it on the top. Or we could have it not close all the way. Where now the issue with that, of course, yeah. It's almost like we can interpolate the top and bottom with one bit, or connect it with one big n-gon, and then do this. Either way, so let's say we go with this for now. So there should be a lot of hexagons, and if that is the case, it needs to be not as tall, right? I can also stylize this a little. It needs to be either not as tall or there needs to be more vertical instances. So what if I just spitball in here? What if I join these together? This transform, all I do is bring it higher. Maybe. So just to show you what I'm doing, what I'm thinking here, is we have our hexagon pattern. Looks like that. I do the instancing, and then I wrap it. But if I want to have a denser thing, the instances should have more vertical stuff, and then I compress them back down. And luckily, that doesn't change the X range. So how do I want to do this? I could do it after the fact is basically what that means. So let's try that. This one I had a sense would be kind of a complicated Nodevember. Okay, so we have this. I want to add more stuff. So I can transform it and join such that these are almost 2 units high, although now we have kind of a similar issue as to what we had before. But let's say we roughly get it correct. And then I transform such that this is a scale of 0.5. Now we've doubled the density. And then if we were to plug this in, now it's still going to be sharp, but not as sharp on the bottom, which is good. So I think no matter what, I definitely want to have one iteration of this. So the question is, what is the height? What is the height of that? And interestingly, it's very similar to the X range issue. So let's see, what do we have in here? We take the Y coordinate, we check where it's equal to this, sample index. I think we do want a modification on this. So I'm going to open this up. Let's say we have this. I want to know its Y resolution or Y dimension. So I do this, right, which will tell me the top and bottom, or it will let me kind of get rid of these sharp points here. It's almost like the height of this isn't exactly the height, but we want to start from here and end up here, I believe. So kind of a very similar issue, maybe. Let's think about this. So instead of seeing where it's equal to the tip, how about we run a compare to halfway with an increased thing. So now I'm kind of looking at the very end points, and it should be 0.499999. Great. Set it to not equal. Now we've isolated the tips. And I want to run this through here. So now this is the same geometry, but I got rid of these two tips, and then we have this number right here, which if we combine into the Y socket, will represent our Y scaling. Okay. Then what happens if I take this and then did, no, we need this in the Z, and then do this? Doesn't like that because because of something. Field range because we care about the Y. Okay. Did that work? No, there's a bit of overlap. Oh. Oh, I see the issue. I think the issue is right now we have these, so if we were to glue the ends together, they would perfectly fit. But if I do it this way, and I glue the ends together, the corners are like this. If that makes sense. They're one offsetted of where they should be. Which would make me think that the solution would be to just get rid of one of these rows. Right? Because I think fundamentally the logic is fine. Easy for me to say. It's so hard to see what's going on here. Yeah, you can see they're like offsetted perfectly by like a quarter of a thing. Okay. So what do we decide to do? What do we decide to do? We want to increase the density, but don't want to frick around with this. Well, I guess could we almost... What would happen if we subdivide? If we subdivide, we get a bunch of nonsense. And then if we dual mesh that, now we get an even more complicated pattern. Weird. Did I merge by distance at the end here? I did not. Okay. How do I want to do this? Before, after. In a way that did double it. In a way. So if I look at before, we have these stretched hexagons, and now I doubled it. And these are all still hexagons. They're just not perfect hexagons, which you could argue, is that something we want, maybe? Ooh. Maybe. And then if we run this set position operation here, then we still get quite good hexagons, just... Okay, I think we got to cut our losses. I think we got to cut them. Just get rid of all that nonsense. Or what I mean by that is to just do this manually. Because we don't plan to change. So that's why I'm not feeling too bad about that. So I'm just trying to merge these like this, but they're like half an iteration off. So it's like we want to spin this on the Z. Like that. Yeah. And then I merge by distance so that they're actually connected. Give it a bit of threshold to work with. Okay. Before, after. Just double the resolution. And then I'm also, so let's compress that. This is our doubling. It's very approximate, but roughly correct. Any insights here? Yeah, the bees would not like those hexagons from before. So I'm going to do that. This is going to be our doubling. Okay. This is going to be our doubling. And we could also do the same thing and make it 4x. So in that way, we could also make that procedural. Double height. Double Z resolution. Now, again, the only caveat of this is if I change this, it's now, I mean, that's pretty good. I was going to say it's going to be slightly off, but just barely. Like that, honestly, that's passable. So let's bring it back up to 6. This is what we then do that like stretching operation to, and we're almost at an hour. Bro's got to speed up. Although this is kind of the harder part, I think, actually, compared to the bees. Which might sound like a silly statement, but I think it's true. Okay, so we got kind of a skinny hive. Flat bottom, flat top. Okay. Yeah, and then we get that stretching. Okay, we'll call this good enough for now. So we got our hexagons, and then if I didn't double the resolution, I'm glad I did that. Okay. So this can be considered our shaping. And we got to make sure at the end we merge by distance. So these points at the very top here end up actually connected. And if we wanted to do more cleanup, we can actually isolate the top sections and do operations to that. Okay. So this goes here, position, combine. Okay. So now we have that. And how do we get an actual, we have the hex pattern, but how do we get this hollowed out thing? Well, now that we've done this, I can use my extrude mesh, make sure to set this to individual, and we just set it to a negative number. Great. Although, now we have this issue where there's like infinitely thin lines between them. So we want to make sure to inset a little. I did try to make a node for this. Let's see if it works. It wasn't designed for this use case. It's also slow, apparently. No, let's not use that. Overkill. So what I'm going to do is I'm going to extrude, and I think this would be a good time. Let me see if I can turn on wireframe. Okay. That's better than nothing. Okay. So we got a bit of a wireframe going on here. And how's our face orientation? Okay, that's good. What was I saying? So we have our extrude mesh. You can't really see the difference, but if I now scale, you're going to see kind of vaguely looks like a inset. And it kind of is what it is. That is what it is, but it's not a even inset. So here is before and after. So I've insetted each face. And maybe a good way to look at this is I'm going to split by index. I'm going to separate by index, cgmatter.com for that node. Let's separate the face that's equal to 0. So I'm just isolating a face. So you can see it's kind of like an inset here. And then the idea would be we then extrude that, so only that top selection, by some number. And that should make good geo. So let's get rid of that. And now, I think that's pretty good. Might want to increase the resolution just a little on the Y. But that's the pattern we were looking for. Okay, great. So now how do we get this to be a bit closer before we have like bees go all over this? Do I need my double resolution? I definitely do. And then the question is, do I even want a triple resolution? I might. I think I do. Well, if I triple the Z resolution, I then want to make sure that I transform this down not by a half, but by a third. And now that looks more even. Good. And I believe if we go back to our hexagon pattern, as long as I do this proportionally, you can get like the kind of spacing you want. So I'm going to do 15. Okay. And we just need to fix our logic. But I'm just going to pick a number I like. So let's do 12. Great. Now I go to my triple resolution and just fix this a little. And the good thing is whatever translation I do here to connect them has to be the same over here. So I can combine X, Y, Z and just figure out what that should be. Okay. So what is that magic number? Something like that. And then just a little. There we go. As long as they're vaguely close, they'll snap together. And then this one, does it go by the same amount? It does. Okay, so this can also be a combine X, Y, Z. But for that tiny number. Whoa. Did that do it? I believe it did. And just to be sure, I'm going to merge by distance with a bit more buffer room. Okay. Sheesh. Sheesh, sheesh, sheesh. Cool. So now we have our hive. I can choose, by the way, and this is very cool, you can see the spacing between these is quite thin, right? And that's what that scale inset does. So I can make that super thin. And then I guess in a sense, they go really deep. I don't know how beehives work. I got to rewatch the bee movie. Let's do something like that. And I wonder, now that this is fully connected, at least it should be. Let's see, merge by distance. Yeah, that's fully connected. If I can do a blur position on this, what would that look like? Okay, it would look like that, which makes sense because there's not much geometry on it at all. So blurring is quite intense. So maybe we SDF this bad boy and then smooth the top and bottom and call it a day, you know? What did they do here? It does kind of wrap around. Okay. Okay. Oh, by the way, just out of a thought, icosphere, high resolution, dual mesh. Kill me right now. No. Okay, no. Because some of these are hexagons and some of them are pentagons. But I guess these are kind of smooth. And then, oof. 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 Don't do it to me. Ooh. Ooh. Don't do it to me. I can't handle it. Okay. It's a better solution. There's nothing to be said. We're doing this. Like, you know, I want to be like, oh, mine was better. Okay. It is what it is. So we have this, we have that, we have this, and then we shape it. That killed me a little on the inside. Oh, and this is so much easier to control. Okay. Yeah, and the hexagons kind of fit a lot better. There's the occasional pentagon, but nobody's going to see it. Like, I don't even see it right now. At least not all our work was for naught, but a lot of it was. Okay, top of the beehive seems quite flat. Yeah, yeah. Okay. So we have our icosphere that we dual meshed and then did shaping. And let me just make sure that this is a better solution before I commit. So I do all that. I throw it in the same logic here. Then I can easily control the resolution, huh? The only thing is I kind of run into the same issue with the horizontal thing, but this is worth it. Okay, this goes in the archive. Archive. I don't want to get rid of it because I did make it. It's the journey that matters. It's optimized. It's optimized. Okay, okay. So we have this, and to smooth it out, okay. So we have our icosphere that we do the shaping to, and then we do this extrude thing. So that can be a node group. And what do I want to control? I want to control the inset, and I want to control the extrusion. I guess I am happy that I had that insight rather than not and making a fully functioning tutorial live stream, but then like, oh, I could have optimized it better. Okay. So I'm gonna... Another thing we can do is now that we've got our senses, we should start adding some, detail to this. So what I mean is, for example, right now I'm scaling, I'm insetting by the same amount, but who's to say I don't do it by a random number? That way these aren't all the same, all right? So maybe I go from 0.98 to this, or no, to this. And now this kind of controls a randomization thing. And then same thing over here. And I can make these vaguely make sense by having the maximum be this and the minimum be half. So that it always goes in, but we can decide by how much. And then for this one, we inset. How do I want to do this? So no inset means 1. So maybe I take 1 and I subtract this number. That can be our maximum. And then our minimum is going to be vaguely the same thing, but this time we multiply by 2. Yeah. I think that makes sense. So now the inset should be a really tiny number instead of what we had before. Okay. Okay, so now that is nice and compressed. So I'm going to call these holes, maybe. Does keep boundaries do anything? I assume not. Okay, great. So now we have procedural holes. So what do I want to... Maybe instead of divide by 2, I want more variation. So like divide by 4. Okay, so now they're not all exactly the same. And what? And now we do SDF so we can actually shape this nicely. So let's do mesh to SDF grid, which will look like this. And I'm happy it computes as fast as it does. I mean, it's kind of a low res one right now. So I always like to set a low threshold and then a low voxel size. We'll see how small we have to go. Pretty small for it to actually get this detail. 01. Yeah. We only have to do this once. Okay, so now it's one nice mesh, which will let us distort it quite nicely. Let's just make it a bit more extreme. Okay. So I want to make sure I'm happy with this shape before I continue, because I think I'm just going to bake it and then go on from there. So maybe this could be our icosphere group. Okay. This can be our remesh group that I have a voxel size. And then all of that I'm going to bake, making sure that I do it on disk. That way it doesn't take forever to save the file. So I would always recommend this. It makes it a little harder to ship the files because then you have to, ship the folder that comes with it. But I do believe it's the way to go. Okay. So we have that. Now that we have all of this, let's do our distortions, of course. And now this should operate quite fast, I assume. So let's do a low frequency distortion just to get a not perfect shape. So vaguely, this is what I mean. Okay, so now it's not a perfect shape. And then a bit of high frequency noise. Yeah. Okay, now it's starting to look quite good. Okay, 07. Okay, so this is our distortion before, after. Great. Now, do I want to do honey or do I want to do bees? Probably honey, because I think what I'm going to do is the bees are going to walk on the surface, and we can consider the honey to be part of the surface, maybe? Okay. Well, for the honey, what I'm thinking is each hexagon is basically an opportunity for there to be honey. So maybe this one belongs to one bee and there's a lot of honey. This one barely has any. This one's overflowed. Flowed. And then we make an attribute for each of these. We bake that, and then we can spawn honey based on that. So if that is the case, we can do this before the remeshing. We have these, and I essentially want to isolate this selection. How do I do that? I isolate the selection. This part might be a bit tricky. I have this. I scale, I extrude. I could just do it based on normal orientation. Or I could just have the honey kind of be an extrusion outside of here and kind of be goopy. That would definitely be easier. And it would be subject to gravity, but because it's so viscous, right? We start like this, we go like that. Let's make this a selection. So I'm going to make a selection that takes this and isolates the top, I believe. And let's see what that looks like. So we have our mesh, and then we have this like interior one. And I can use this as a proximity map, I believe. And that way I don't even need to rebake anything. But then they should be distorted as well, right? Right. Okay. So this can be our, whoops. So I just want to make sure. What do I want to make sure? I guess, wait a second. I don't think I do need to break apart this distortion. I'll tell you what I'm thinking right now. I want to store this thing we made before we do the distortion. So maybe let's store a honey attribute. And that is first of all going to be based on the proximity to the nearest face. Yeah. The proximity to the nearest face. What does that look like? Okay. Good. I'm now going to invert this, so the interior is what's kind of the strongest here. So 0 to 1, 1 to 0. And then we want the threshold to be smaller, so I can't search that far. Okay, so you can see how I'm making this over here. Like that. Okay, so now we have this map of what is the interior. And the nice thing is this comes along for the ride, so it distorts with it. But additionally, each pocket should represent a different amount of honey. Now, what I'm thinking is this will not only tell me the distance, but for each of these, it will give a position. And that's per face, okay? So each thing has a face. And it's not continuous. Maybe. No, it is continuous. It's continuous AF. Okay, new plan. I'm going to sample the index, and I'm going to sample nearest, so not much changed. Except this time, I'm going to have more control. So I'm going to take the selection. I'm going to look for the nearest face. That is going to be relative to this geometry. And then for this index, so what I'm trying to do here is I'm basically trying to make a randomization thing where each face has its own value. So I look at the nearest face, and maybe this index goes through a white noise texture. That seems fine, right? And then instead of going 1 to 0, it goes whatever this is to 0. Okay, so now if we view this map, yeah, great. Okay, so I just sampled the nearest face, and I said for that thing, run it through a white noise, which effectively just randomizes it and puts it between 1 and 0. Great. Of course, we do 2 evaluations, but that's fine with me right now. Okay. Cool. And then we can spawn honey or whatever based on that. Okay, I feel good about that. So we could spawn honey everywhere, but make it very sparse in some areas, like the radius. Or we could make the honey only exist in certain pockets. I think that's kind of the fancier one. Okay, so I'm going to distribute points on faces, but not for every single face, and this will be way bigger, like 1,000. Not for every single face, but based on this map range. So first of all, I can see which of these is greater than 0.5. So let's see what that looks like. Greater than 0.5. So that's only going to be some of these, although it's also range dependent. Okay, okay. So it's also range dependent. I could just spawn it everywhere and use this as a map. That wouldn't be crazy. Oh, wait. I want to make sure I'm using the attribute that it moves with the distortion. Okay, so we have this, and let's say I took the honey and I check where it's greater than 0.5. Okay, there we go. So that will only give us some of the pockets. So on some of these pockets, I can distribute points. Great. I'm going to make these much smaller so that I can see them and also that we can remesh them. Let's make this 10,000. There you go. Even smaller. What did I just do? And I take whatever we did here and I combine it with this. Okay, so now we got little pockets of honey in some areas and not others. Great. Do I want to turn this into a group? I do. So this is going to store our honey attribute. So this could be our hive. And then the other thing were those faces that we separated. So maybe like pockets or something. And it's going to output the hive. Great. Okay, then we distort these. And this is going to be called store honey. And now we spawn the honey in certain areas. Great. And then in that case, did I ever really need the proximity map? Let's see. Yes, because it's only in certain areas. Okay. Let's make more of these, and once we're happy, we can bake these in. And this needs to be kind of its own SDF or whatever, because it needs to be kind of a liquidy goo. There is a node for this. It's points to SDF, which is different than mesh to SDF because it's actually going to look at the radius attribute. So I plug this in here. I take the grid. I make it a mesh again. And this one's going to have to be detailed. So for the radius, let's use the radius attribute. Make this tiny. And then make the voxel size tiny. It's got to be real tiny. And as long as it computes fast, I'm fine with making it smaller. Okay, so what does this look like when I combine it? Okay, now we got little pockets of honey. Fine. Let's make that even more detailed. Okay, now we're starting to run into the limitation. So we have these little pockets of honey that look whack. So maybe I'm going to take the radius and make it a bit bigger so that the blobs are kind of closer together in a sense. So I'm going to take the radius. And not only that, maybe we should randomize the radius. So instead of going 0.003, we go 0 to 1, and then we multiply by some small number like 0.005. So it's going to use this as the radius. Then I can get rid of this. And basically the idea here is if the radius is bigger, they're going to glob up. Yeah. And it's going to be nice and random. There we go. Little honey. Great. And then we can take all of this, and if we so choose, we can blur the position. Okay, now some of them have honey and some don't. And to get this idea where some pockets have more honey than others, we can use this. So if we look at our point distribution and we look at our honey, you could see some points are bigger than or brighter than others, which is hard to see until I set the radius. So you can see some of these are brighter than others. Yeah. Technically true. So this honey goes from 0 to 1. So maybe we add 1. So instead of going from 0 to 1, it goes from 1 to 2. And I can use that as a scale. Okay, so sometimes the radius will be even 2 times bigger, maybe. But I want to make sure I have the white noise. Let's see. What happens if I plug this in here? Okay, so now some of them are now coming out. Let's make this tinier. I think that looks a bit better. Makes it look more goopy. Cool. Yeah, so this one is quite sparse, for example. Okay. Curious why the execution time looks like that with all these SDFs. Because the SDF calculates the nearest point, so it calculates the distance to the surface, and that is dependent, one, on how much voxel size, how much resolution you want, but also how many faces does it have to look at. Because if it's only looking at a cube and it's seeing how close are you to the cube, quite easy. If you're looking at an icosphere with like 1,000 iterations, that's where it gets a bit tricky. That's my answer. Consolidation time. Nope. And I hope that I have time, so far I do, to do the bees, because I think that's the interesting part. Oh, and by the way, this greater than's a great filter. If I make it greater than 0.8, almost none of these are going to have honey. If I make it greater than 0.2, almost all of these are going to have honey. So kind of a cool way to think about this. So that should definitely be exposed. This is fine. This is, I don't think I'm going to change it. This is the size of the particles used for the SDF. And the reason I'm not using the remesh from before, which does something very similar, is this time it's points to SDF, not mesh to SDF. Okay. What do we got? So we got our point distribution that have an SDF, and then we blur it. Okay. So all of that can be a node group. What do I want to control? I want to control the probability. And really, it's like an inverse probability, but that's fine. I want to control the voxel size, and I want to control the number of blur iterations. Okay, great. So this is going to be our honey, whereas this one was our store honey attribute. Cool. So now we could do bees or we could do material. And I think this is actually something that's quite subsurface. Usually subsurface is seen as like you put subsurface on everything. That's how I see it. In this case, I think it's fine. So I'm going to make two materials. I'm going to call it wax, which is what the hive is made out of. And I'm going to call it honey, which is what the honey is made out of. So I'm going to set material for each of these. So this one gets wax. This one gets honey. We're going to need a sky texture to see any of this. What does this say? Sun disk not available in Eevee. You might think that's an issue, but of course not. Cycles, GPU, view, connect, beehive. Great. So this is adequate lighting. And now let's see what I can do with the wax, where we add all of this detail. So yeah, let's start with the wax. That's the important thing. So for the wax, it first of all needs to kind of be this milky yellow. Do I have this inverted? Oh, wait, yeah, do I have this inverted? What is happening? Oh, there's just that much honey. I see. Okay. So this should be kind of like a creamy thing. We're going to add lots of subsurf. And then the question is this to scale? So I'm going to say a hive is like 1.5 feet. Let's call it that. So right now it has a height of 2 meters. That ain't right. So I'm kind of scared to do this, but I'm going to scale it by 0.4. So now it's roughly correct. What I'm worried about is if I apply scale, which is necessary for the shader, I think, it might create more points for the honey. Let's see. Wait, what? Apply scale. What? I don't get it. Okay, no matter. We transform at the end. So now this has a scale of 0.5. No, of 0.3. Okay, so now this is closer to realistic scale, maybe. And now you can really see the subsurface come through. So without, with. And then it's kind of like looking creamy yellow. I'm not quite sure. Let's try translucent. At some point I need to watch some tutorials about materials. So I'm just kind of comparing. I always compare translucent versus subsurf. So this is like yellow. A very yellow yellow. Then this is a red, green, blue. So I guess I'd want a lot of red. I don't even know. Okay, so this is fine. This is going to be how much light penetrates. And it's quite thin. So let's say 1/2 inch. I think you can just type this, 0.5 inches. Cool. It's quite shiny, even though it's the honey that's shiny, but let's say it's quite shiny. Great. Let's say that the wax should be super detailed, I assume. So I'm going to do a noise texture going into a bump. Very high resolution noise texture with detail, with roughness. And this is going to be our normal map. I'm going to turn off subsurf just to see what's happening. Okay, so even more detail, even more roughness, just until it's this very coarse thing. And also, this is telling me, with its great wisdom, to set shade smooth. Okay. Before, after, strength of a half, subsurface on. What does that look like? That's looking creamy, right? There's cream. Perfect creamage. Okay. We can also have the color vary as it goes on the interior, but for now, let's try the honey material. I love using the sky texture. Thank you, Oma. Very nice. Oh, and I should mention, by the way, all the free nodes I used are actually free. You don't need to be a member of my website, but you go to cgmatter.com, you go to free nodes, you select this, and also all the Nodevember stuff, including whatever it is I make here, will be available. So here's the other stuff. And before I continue, during this live stream, we've been going for an hour and a half, which means right now it's 3, so 1:30. So during this live stream, if you're watching, so these are the people who joined the member part of the website. Thank you, Sean. Although that was a bit before, so actually not Sean. Thank you, Sean, but not Sean. Thank you, Christian, and thank you, Ashley. We don't get, well, I guess Ashley is a unisex name, but thank you both. Thank you both. Okay, honey. Honey, what is honey? Honey is a sweet thing. No. Honey is a transmissive, orange, shiny liquid. Okay, so that's a start. It's looking whack, but we're getting there. It's looking whack because it's a little too saturated, a little too red. Oh, wait, that's value. A little too red. That's pretty good. What's weighing this down? I assume it's the subsurf that's weighing this down. If I turn off subsurf, yeah. It's the subsurf that's weighing it down. So could we approximate subsurf without using subsurf? It's like that translucency, right? That might be a good way to approximate it. What if I add these together? So that's a no. What if I mix these together? If this works, it's just substantially faster, is why I would like it. So before, well, that's full transmission. So before, after, versus, what are we competing with? We are competing with this. I don't think that's much of a difference. Right? That could work. Should it be the same color? I don't know. The subsurf, or sorry, the translucency is pretty milky white, whereas this should be more yellow. And we can always fix whatever mess we make in compositing. It just doesn't look yellow enough, does it? And it could be the fault of the lighting. What about the roughness? What about, oh wait, subsurf stuff. Okay. Let's play with the honey. I think one thing we need to know is the, I don't remember. One thing we need to know is the IOR, the index of refraction, how much light bends for honey. And this is always the go-to resource. So H for honey. Okay, honey, 13% water, 20. I feel like bees would make the least amount of water, just pure fucking honey. So that's 1.504. 1.504. Maybe a more orange, darker? Darker honey. Yes. Yes, yes, yes. Less transmissive, more transmissive, more roughness, less roughness. I don't even know. I think the main limiting factor of us like testing this is the sky texture. Like when I turn off the sun disk, it's much easier to see. So maybe let's make the sun disk a third as strong as it is. Okay. This should be pretty high up. I'll call it 1,000 meters. And what about the lighting? Yeah. And I know it needs to be more yellow. I'm working on it, okay? I'm working on it. As we go into the interior, it might just be the shadows, but it looks more orange. Regardless of if that's the case, we can mimic that either using an attribute, which we might be able to do. Let's see. Attribute, honey. We could do that, and then they're different. Let's try that. So I'm going to use my honey attribute for stuff. So initially, it's going to be this color, and by that factor, no. Hue saturation value. Delete, god dang it. Hue saturation value. Initially, we start with this color, and then based on this factor, we darken it or something. So let's see. This is what we got. I darken and saturate. It's hard to tell. I'm going to try mixing as well. See which one feels right. This one feels right. Okay, so I connect that in here. Before, after. Who knows if it actually did anything? What if I make it black? Is the issue the specular? Is it specced out? Specular. Don't even know. Well, one thing I do know is the translucent C should also be subject to the bump. And the honey is looking quite dark. So for the honey, I make it a little brighter. And a little less saturated. I think the only thing that's giving me pause is the subsurf. Like the subsurf is a big deal. Like whatever we pick here matters. So what if I make it like 3 times as thin? Yeah, it's not yellow enough. Oh. We have money, people. Let's show the money. Let me make sure it's a nice comment. It is a nice comment. Okay. Thank you, David S., which I recognize your thumbnail, your avatar. I joined your website last night after stream. Wish I had the time to really dive into the massive amount of content. I joined mainly as back pay for everything you've taught me over the years. Thank you. I think that deserves a heart. Imagine I just like dislike. I'm like, fuck that. Okay, thank you. What else? Hue saturation value. Do I just like darken? Interesting. Just a little. And then I wonder, I mean, usually I play with this in compositing, but to get like yellows, which are notoriously hard, different color space. So right there, you saw already more yellow. Different color spaces help with that. But let's say I was to use that. Then yeah, the subsurface crazy. So let me make it partly strong. Then what is it that's whack? Is it the bump? This is like reminding me of Cheerios, which I guess is a good thing. You want that. It's vaguely. Oh yeah, that's why they made it look the way it does. Of course. Metal. In a way, it does look better, but it's not metallic. People are saying aces. Well, I'm not impressed. But I know that I'm not using it correctly. That's fine. I know another thing is everybody does this. This is the, if you watch, there's some dude. I think it's like Christopher. Let me find the dude. Yeah, it's Christopher. There's this channel called Christopher 3D. And he keeps talking about the color. Like it doesn't end. But what he says, and I trust him, he sounds knowledgeable. What he says is take this, make it Rec 2020, click apply, and that will just give a bit more dynamic range something for the internal calculations. I don't actually know. I don't know. What else? What else? What else? What if I make this like 3 times more intense? Okay, so obviously that's much, but it does remind me that we do have access to like, you know, distortion and stuff like that. What if I make this detailed? Yeah, why not? Let's make it detailed, a bit rough. And then what about this? Detailed, a bit rough. Okay, that's a bit too rough. And then also, because this is all fully prestige, well, we do need a bake. We can turn down the number of subdivs, maybe? Because I think this is, no, that's roughly correct, the number of holes. I think what isn't correct is these walls need to be so thin. So thin, so thin. So I'm going to do that. I'm going to make them thinner. And then to see that change, let's see, we rebake. How's that doing? Yeah. 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 Okay. Yeah. So the main thing is the yellow ain't yellow. The yellow should be yellowing a little more yellow than it is. Oh. Oh. Then what if I do the opposite? Uh-huh. Clearly that's what I wanted. Oh. Okay. One thing I'm noticing is the honey distribution's way different. Let's see. If I bring the probability up to 0.7, now there's less honey. If I make it 0.3, now there's lots of honey. I think lots of honey actually looks better. I'm pro honey. 0.275. Like, you know, maybe this hive is very successful, and more importantly, it looks good. Yeah. That's pretty messy. It's pretty freaking messy. But that's okay. Now, I did promise bees, and I will try. I will try. But first, yeah, I just don't know how to work the surf. Oh. I'm kind of liking a bigger number. does make it look kind of tasty in a way, right? Okay. I think another thing I just thought of is why don't we take the honey, and it's going to be in the pockets, right? But what if we also distribute just some everywhere? So 40,000, it should be way less. So let's say 1,000. And let's say I was to join them together. Is that a thing I like? I can't even tell. Here. So this, oh my frickety. What is happening here? Why is this different? Oh, it's just a mess. This, what I'm about to do, is purely for visualization purposes. Do not try at home. Although now that I think about it, if I set this to the radius and then I do the radius, that's a bit more intuitive, right? Okay. So what was my point? My point was this is what we had before. And then, oh, I didn't connect anything. And then this is what we have now. Just a bit of extra honey everywhere. What does that look like? I want it to just look a bit goopier. Okay, cannot tell the difference. Let's bump this bad boy up. 10,000. Yeah. Now it just looks a bit stickier everywhere. So before, 0. Very clean. And then after. Just kind of goopier. But I guess also it wouldn't be that effective given that it's a proximity-based effect. But let me just try 40,000. Yeah. Okay, this is definitely the right direction. Now it's looking more like, oh, bees, run away. I'm liking this. Also, by the way, if you see this, it's sampling. How do I show what I mean? So if you look at the text info at the top, you see there's 1,000 samples. It goes and then it just stops. Doesn't need to do that. It can keep going. So I'm just going to turn this off, make this bigger. Now it's allowed to go higher. And the denoise. The denoise, though. I don't know. Do I want the denoise? No, I don't. Think of the scale again. Seems obvious, but getting the background right so the lighting fits. Needs to blah, blah, blah. I guess the sky texture is making it all flat. Try it different. No HDRIs. No HDRI. Nodevember. Does an HDRI sound like a node to you? I definitely did that previous years, but I'm going full node. But you are right that the lighting is really shaping this. Like, it can look good, it can look bad, depending on certain values. Yeah. Okay, let's say we're happy with this. Okay, fine. How would we make bees walk on the surface of this? How would we make bees? Well, the bees should almost be avoiding these cavities, not as in they're not getting close to them, but they don't like fall in or anything. And this will really give it a sense of scale as well. So maybe a bee is roughly 1.5 times the size of a cavity. They should just be walking on the surface of it, and that would also make it easier. So what do you see? We have a icosphere. That icosphere we shape. Then we put the holes. Then we distort. Okay. How do I want to do this? I think here's what I'm going to do. I'm going to turn this into a node group because I'm going to need this distortion to I don't know what the fuck that was. I'm going to apply this distortion again. So I'm going to need it as a node group with identical settings. So here's what I'm saying. I have the icosphere, I have the shaping. I don't do the holes, but I do, is this place haunted? The distortion. Okay, so these are like vaguely equivalent, but one doesn't have the detail that's unnecessary for the bees. And this should compute fast. So we have this baked, we have this baked. Let's just say that whatever we got going on here, we're happy with, just for now. This can go on later. Okay, so this will be useful later. Fine, so I can take all of this, just move it up. And then we have our sad little archive, how far we've come. Okay, so we have our hive, and what I want to do is I want to make points. Each point represents a bee, and they move on the surface. So first of all, we got to do these points, and then we got to make those points bees. So I'm going to distribute points on faces. These should very importantly start off spaced apart so that they don't collide. So I'm just going to max this out. There's going to be bees everywhere. Even more. Okay, so each one's going to represent a bee, and somehow we need them to move in a way that feels right, but they're also on the surface. So just a reminder. Here I have some good reference. By the way, yesterday I learned you can totally play a GIF, which I did not know. Cyclic, refresh, boom. So they're almost just not moving in a way. So that was a fun fact I learned recently. So what I want to do is these points should be moving. Okay, how do I do that? Well, probably a simulation zone is cleanest. I was thinking this could be totally deterministic, but I'll do it as a simulation zone. And then what are the rules? Well, on every frame, each point is going to move some amount. So let's call that amount a noise texture, which is going to represent a velocity. And I scale that velocity by delta time, which I have a node for. dt, cgmatter.com. Boom. So now these are just going to go around. Now the issue is you're going to see they converge on some areas. So if you saw my curl tutorial, you know how to avoid that. And they go off of the surface. Well, the surface parts are very easy, actually, because every time, let's say we have this hive, and let's say there's a point. This point goes this way, this way, this way. It represents the bee. Let's say on one frame it takes a step this way. So what I mean is off of the hive. We don't want that, so after it does this, we can just snap it to the nearest surface point, and then it goes somewhere else, snap it to the nearest surface point. So when we do that, it will look like the path is on here. Pretty clean way to do it. So what I would do is I would set position, and then I've snapped to surface as a node. So I believe I just do this. Again, cgmatter.com. And then I select my surface. And now I hope these should move on the surface. They do. Now we still have the converging problem, but they're on the surface. So the converging problem can basically be described as the noise field isn't zero divergence. Have I made a curl node? I have not. So until I make a curl node, I'm just going to have to approximate a solution. So curl node would let them not interfere. And if you don't know what I'm talking about, I did a tutorial on the 27th of October about how to make fields like this. Let me show you. Where nothing intersects. Everything just kind of flows around each other. And that is a curl field. I'm not going to do that. I'm not even going to download and borrow the nodes. I'm just going to come up with a solution, which is going to be as messy as take the noise texture, make it 4-dimensional such that we can animate the noise over time. Now this is important. That is, and let me use my CG matter time node. It's important that this doesn't evolve too quickly. Yeah, so look at how weird this is. Yeah. They're all kind of converging to a point. Why is that? Because the scale is big. No. Oh. Duh. It wasn't in the W socket. Okay, so now we're just trying to get them to move, but not forever. Okay, they still bunch up. Are they like bunching even more now? Okay, what about... Yeah, it's like we really want a curl field. Well, one thing I know is these bees are moving quite fast, which doesn't give them time to diverge. So I'm going to take this, I'm going to multiply by 0.1. So they move 10 times slower. So that helps, but they still converge. And at this point, we can do like detection, collision detection, and have them... Okay, that's something. Maybe I can also have all of these not move at the same speed. So some bees are stationary, some of them are moving. So I multiply this speed by a random number. So some of them are going to have full speed, some of them are just going to be lazy. That's better. And assuming we don't give them enough time, they won't converge. And we could do collision detection. But if they just chill out, if they just chill, it should be fine. And of course, we can start them spawning further apart. Okay, so kind of the idea here is now we have this. Fine. And I want to spawn bees on it. So we don't only want each one to inherit a bee, but it should always be pointing outwards from the surface, and it should be, if it's traveling this way, it should be pointed the way that it's going, which is important because some of these rotate quite quickly. Well, we know that its velocity, where it's going, each frame is basically dependent on this. Or actually, it's dependent on this. That is the velocity, which tells you exactly which direction it's going in. So maybe instead of just doing an offset, I'm going to store an attribute. I believe, do I have a node for this? Calculate velocity. No, I don't need that. I just need a store. Store velocity. That's a vector. That's going to be this. It actually doesn't matter if we scale it or not because we're going to normalize it for the direction, but whatever. I'm going to store the velocity. And then I'm going to use this velocity to offset. So no difference, really. But one difference is now I can package all of this into a node. So be velocity and be proud. Okay, so that. Okay. Yeah. So now if I can make a bee, well, first of all, let's make sure we can get this working. So we have a point, fine, and we need to find the normal. Okay. So let's say on each of these, I instance like a little bee. That bee can be represented by a cylinder. The important part about the cylinder is that you can tell which way it's facing. So in this case, it's facing this way. If I rotate it, it's facing another way. I'm going to instance, and I'm going to make the scale very tiny. 0.05, or actually we have a radius for just this reason. And I'll make them 2 times bigger. Okay, so here we have a bunch of bees, and they're always pointing upwards. We want to make sure that not only are they pointing at their velocity. So, okay, so here's roughly the idea, just so I show you. This is going to be wrong, but just so you see. I'm going to set the rotation to something, right? And that rotation ultimately will be dependent on the velocity. So, you know, they're not correct, but you can see they're trying to do something. The issue is this velocity is just the direction it's going in before it snaps back to the surface. So if you were just to look at the velocity the way we did, so we have this, it goes this way, and then we snap it back to the surface. If you look at the velocity the way we stored it, we're just looking at this arrow. But really, we snapped back on the surface, so it's this that is our velocity. Okay, so we need to capture that, and that's just saying where was it, where will it be, yada yada. Okay, I can store position, which I have a node for. So by default, this will take some geometry, and this actually needs to be before. So again, cgmatter.com for free for the nodes. This will store the position in something called old position. Then we move it. Yeah, then we move it. And we move it again to snap to the surface. And we can calculate our velocity like this. And then I store named attribute. Nope. And I'll explain what I'm doing in a second. Okay, then I store the velocity. So calculate velocity, all it does is it takes your position, it subtracts the previous position, so that tells you the displacement, and then it divides by delta t. Okay. So really this calculation is independent of this one, but this is the one that's going to be written out here, and then a different velocity will be used for calculation. So now, I believe this will be right. Align rotation to vector using our velocity. That's different, but the motion is going to be the same. How's that? Yes. Yes. I don't know if you can tell. Let's follow one specifically. So I'm going to follow this one. You see how it's kind of, so here it's deviating a lot. But you see how, right here, you see how it was kind of pointing in the direction it was moving? Just like that. Cool. Now this tells me that these rotate far too often. And that is a result fully of this noise. So let's see what happens. If I make this 0.1, is that more stable? Yeah. Yeah. And then the noise texture in itself should be less detailed. Yeah. And especially if you don't see it from super up close, that's pretty good. So now the name of the game is just instancing the bees, like we did it. Okay. So we take the cylinder and we replace it by a very simple bee. And I mean very simple. Famous last words. Okay. So the cylinder, not good enough. We're gonna use we're gonna make a bee. So maybe all of this, yeah, all of this I turn into a node. So I'm gonna call this move bees. It outputs the bees, it inputs the bees, and we also need the surface. Okay. And then this I can actually move inside. You like jazz? Okay. So we got a bee. And then we need the cylinder to be something better. So I'm just going to make an approximation that wiggles its feet and flaps its wings, I guess. Okay, so what is a bee? It is a sphere. So that's going to be this part. We then take another sphere and join them together. So this one's going to be, it's going to be like that. 2.5, and then wider. And again, I'm just banking on it being far enough away that you can't tell. Okay, and then it also has a head that I'm going to use another transform. And this head seems lower and kind of skinnier and kind of rotated downwards. Okay. And note, everything we're going to do, we're going to merge with an SDF. Whoops. And maybe for all of this, for reasons like last time, I'm going to use an icosphere. Better distributed geometry. That's going to be important because I think I want these lines. But before that, let's make little, I don't know what they're called, little antlers or something. So that's going to be a curve line. I'll do this here. That's going to be a curve line pointing up on the y-axis. So that looks like that. Maybe a bit taller. And then I move it. To be in the right, in the right place with some rotation. And then I'm going to make the exact same one, but this one's going to be flipped on the y-axis. No, on the x-axis. Now this might be also something, so I want to do these tiny little animations to be like, oh, they're doing something. So to do that, I need to separate these, which are curves. And what the curves do is they wiggle. They wiggle a little. So to do that, I'm going to resample the curve so that they have a lot of geo to work with. I'm going to distort cgmatter.com, the curve. Low frequency, low strength, even lower frequency, but higher strength. And they should only wiggle the tips. In other words, this section should be pinned. That can be approximated using a spline parameter that goes from 0 to 1. And yeah, And that's going to be the scaling factor for this vector that I'm going to call 0.4. Although, if these are all the same, I can plug them in here. So now, let's see, before and after. It's a little hard to tell, but I believe only the tips moved. Yes. Okay. And those should also be moving over time, like it's calculating something. So the coordinates are going to be the position with some offset. Okay, so you can see they're kind of communicating there. And that is going to be subject to time. No, the CG matter time node. Brilliant. Okay, so that's a good start. You can see it's kind of like too wiggly. So what if I did like 4 points? Yeah. And they shouldn't really be compressing on the y-axis, really. They should just be going left and right and maybe up and down. So maybe for the strength, I do that thing I was saying before. So they can go on the x, they can't on the y, and they can a little on the z. You know? And those are usually more sporadic motions, so they go a bit faster. Even a bit faster. Oh wait, wrong direction. And then once I have this, that's that low resolution thing, I can fillet the curve. So this is just to add some curvature. Okay, so before and after. Let's zoom in. Before and after. And then that needs to be a mesh, which I refuse to use the tube node. I'm just going to use my own. So this is going to be a curved circle with a kind of high resolution, tinier scale, fill the caps, even tinier. Okay, so let's say to start, this is our B. I just want to make sure that this is working. If I swap this out as our instance, let's see. So they are rotating, but clearly they're facing the wrong direction. So I wonder, if I just transform, and I don't multiply by 2, but I transform such that this is oriented like, I don't know, upwards. Yeah. It's glitchy, but again, from a distance, it's not too bad. And they are rotating about an axis that they shouldn't be able to. Like they're kind of going like this instead of just rotating on the surface. But that's fine. Thank you for the kind words, people. But you can't tell, right? Can you tell? I don't know. Let's see. Is that something we can correct? I never really remember how this works. So the idea here is I constrain it to a certain axis so that it can't do that. That helped. I think. No. Okay, I'm just going to do auto pivot for now. They'll figure it out. I think also the issue is sometimes the velocity is so close to 0 that it kind of flips. I wonder if you know what I mean. If I go in here, if I can make that velocity always non-zero. I mean, would adding a constant offset even help? Uh-huh. It will help in that way. No, doesn't seem to matter. Okay, problem for a different day. So now I'm going to take our bees and keep modeling them. And the nice thing about these antlers is I can probably use the same logic for the legs without too much work. What do I want to do? Lower res? Yeah. Okay. For the legs, I do the exact same thing. So what do? I transform geometry, and I'll clean this up in a long time from now. So I transform geometry. This one's rotated 90 degrees. So you can see what I'm going for here, right? So this gets a leg up here. It gets a leg slightly below. Why can't I figure this out? Why? What? Oh. It gets a leg slightly below. I'm just trying to follow this. No, it's like up here. This one's up here. Something like that. And I guess these should be longer than the others. And then finally, we get a leg on the back, like here. I think that makes sense. And then we can take all this, which I'm going to join. So we have this one, and this one. So these make up our 3 legs. These make up the antlers. And I'm going to make a copy, just like we did with the antlers, that is flipped on the X. And then all of that is going to be subject to the wiggling. However, now we do want it to also wiggle on the Y. So that's kind of the trouble. But if we can kind of let that slip a little. Okay. Let's also help them out with a bit of rotation. Okay. A little whack, I won't lie. What does this keep doing? Okay, there we go. I don't know how I feel about that. We might just have to call this like a bad part of the thing. But now they're wiggling, and let's see if that gives the impression that they're walking a bit more. Okay, what is going on here? We have this, we have that, makes it smaller, we instance, but it's gone. Why is that? Ah, because it's tiny. Okay, and then we do it like this. Are they crawling on the surface? Ugh. It's the flipping that's got me bothered. What we could do is we can have them always going off of the surface normal and then orbiting, maybe. Like, yeah, that's cleaner. So what I'm saying is to get them to not flip, they're somewhere on this beehive. They should look at where they are and rotate such that their back is facing outwards. Okay, well, if I wanted to do that, sheesh. Okay, well, if I wanted to do that, we need a, not a snap to surface, but surface, nearest surface point, sample nearest surface. So it's going to sample the nearest surface wherever it is. I want it to sample the normal. And if I make this the thing, now they're, you see what I mean? Like, kinda. But they're now not facing the correct way. Like, it's almost correct, but not quite. So, like, now what I would do is I would rotate the rotation on local space, and if I do the Y, this is how they pick where they're facing. It is tricky. I need to think about this. So they go somewhere on the thing. So we need to know the angle that they're facing relative to the normal. Okay, let me at least draw what I'm thinking. I'm gonna have to sit in silence for a moment. But let's say there's a surface and a bee on it. It's got its normal vector. So now the bee is, at least facing outwards, but it needs to know which way to orient. That's what I'm thinking about. And we have the velocity, so that should be like vaguely obvious. But let me think. Okay. Maybe we do a bit of cross product-age. So let's think. If I do this, I would need to account for both directions, which is what the cross product, although I made a good node for this, angle between vectors. So vector 1, vector 2, it will normalize them inside, and I look at the cross product. So now it will vaguely respect both of them. But then I need to rotate about the axis. I need to rotate about the normal by some angle. I might just have to go with the glitchy version. But I can rotate this locally, which I was hoping. Okay, yeah, that spins them on the normal. Okay. By 90 degrees. By negative 90 degrees. Are they now pointing where they're walking? Can you even tell? is that any better than just using the velocity? So we'll see which one visually kind of works better. Is this correct? Yes. Okay. So here is option 1. Here is option 2. And I know one thing to make this more stable, but then we run it into its own issues, is when we move the bees based on some noise, it's this W that's creating the issues. Maybe. Maybe not. That's not bad, right? Oh, I see. It wasn't using that. I know it's dot product. I just don't know how. Yeah. The dot product always gives you the angle between vectors. But I don't know what angle I need. But it is kind of... Hold up. Hold the phone. Axis angle to rotation. We know the axis is the normal. Is that any different? Okay, what about axes to rotation? So let's say one of this is that one, and one of them is this one, and that's going to define a rotation. And then figure out the numbers. Now they're all floaty. Does anybody have an insight? Is lerping possible to slow the rotation when they do not move? That's a pretty good idea. So instead of like figuring out the answer, we like say where it's likely to kind of mess up, we pick something that isn't a big deal. It's not bad. That is possible. So we kind of find high error areas and prioritize those. Okay, I think I'm going to save this as a problem for later, because it is a lot of the way there. And I don't even know if you'll be able to tell, honestly. So now we finish the bee, which was the goal. So now we have this bee, this disgusting, filthy bee, and we need it to be a thing. So let's do SDF, mesh to SDF grid, okay? And let's do SDF to, or grid to mesh. So now we're going to have one nice bee mesh, in theory. Okay, so now we have one nice bee mesh that and which, if you know how Blender works internally, is funny, bee mesh. I'm going to blur the position. And I'm going to take these and thicken them. I mean, the legs should be thicker than the antlers, but whatever. And then maybe also for the noise, higher detail? Low detail? High detail. Oh wait, that's just the... Okay. What was I saying? I was saying SDF, the whole thing. Let's instance a bit of fur, I think might help. So that is this. That's the head. It is this. It's the body. So I'm going to distribute points on faces. And then we will instance on those points a curve line. So this is going to be the hair. And I'm going to take all this. I'm going to join it. So now we have our hair. Which way should the hair be facing? It should be facing off the normal. So we use this rotation. And then we make this more numerous and tiny. So let's go with 200 hairs, and whatever we're doing, we're instancing, so I'm not too worried about the level of detail, at least yet. We'll go from 0.1 to 0.3. We'll go from 0.05 to 0.15, so now we have little hairs. And those hairs should all probably be the same thickness, so I'm going to realize those. Oh, wait. Yeah, that's fine. I was gonna say, oh, the bee's moving, so the hairs have to move, but not here. Here only the legs are moving. And I'm going to mesh to curve. I'm going to curve to mesh. This one should be super low resolution because you can't even see it. Tiny. Tinier. That's good. Do I even need to realize this? I think I do. No. I mean, I would then have instances of instances. Okay, let's make that 500. And that should help. Any little bit of detail is appreciated. Okay, so that nonsense is our bee that I connect here, that I view here, that I zoom in here. And now each of these, if I zoom in, has tiny little hairs. Should we see this in context? We should probably. So that's what all this was. All this was our hive. So I'm gonna, I understand that this is illegible. I'm gonna join these together. So now we have our bees and our thing. We view it. And what does this look like? We have our little bees. Little bees. Incredible. And to view these at speed, the issue is that. But this I can view at speed. So stupid. And I guess the bees can kind of look like they're sideways or something. Okay, let's do a bit more detail on our bee and call it quits for today. So we got this. Okay, let me clean it up a little, because this is truly, truly illegible. So we have our icosphere that I do shaping, I do holes, I remesh, I bake, I do the honey attribute, distort, honey, and then I bake. So long story short, all of this is our hive. And this should help a lot. So all of this is our hive. All of this is going to be our bee motion. Okay. So now we can take all that and bring it here. Okay? And then everything else is going to be our bee. It's that simple. Okay, so what else do I want to do to my bee to add detail? Well, we can go with the tried and true distort node. Lower this, lower that, lower it more, less detail, even more. And that is better than nothing, right? I think that's worth having. We can also have the head rotate and do some parenting, but okay. You know, something that's interesting that I just thought of is all of these, as you can see, are hairs in this fake drawing. Let's just look at our reference one more time. Like, how chaotic are they? Why are they not moving? Like, they're kind of chaotic. It's just that they're not moving at all. But either way, it's like they're covered with fur. And the color can also be in that fur. So maybe... Where's our diagram? Maybe we could do fur everywhere, but a little more here. Maybe. Well, if that were the case, I would take this and distribute hairs on it. So now it would look more like this. There's hair everywhere. However, we can make the hair bigger wherever it's close to the thing. So we run a geometry proximity on the original sphere. In other words, like this part of the body, I know there's names for these, and the distance, which can control the scale. So I'm going to multiply the scale of the hair, can be defined by the distance to that inverted. How is that? Not bad. And it can have a minimum of 0.3. Okay, so as I play with this, you can kind of tell. And this way there are hairs everywhere. Additionally, we need way more of them. Because whatever we do once and then we instance. And then you could argue something. I don't know what you'd argue. But like that's pretty good, honestly. Also the legs, but I will skip that for now. Okay. So let's try giving this a material, see if we can do anything with it before I start like node grouping this bad boy. So I'm just going to look at the bee. On that bee, I'm going to make a material. We'll call that material, we'll call that material B, which it will inherit. Okay. And what is that B material? Well, it's going to be the stripes for sure. But let's do a principled BSDF to start. And we could do a wave texture for the lines. And I think as long as we get this right here, it should transfer over to the instances, I believe. So I'm going to do a greater than 0.5, reduce the number of lines. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 in this not anatomically correct B. So let's get that roughly correct. Great. That is going to oscillate between two colors. Those colors being this one and that one. Okay, and this should look better in context with the principled BSDF. That looks gross. That's better. Okay, so we have that. But they're not like that everywhere. At a certain height, okay, let's look at real reference. What am I doing? At some point, it goes full yellow or something. So to do that, I can look at, and let me make sure that this actually transfers. Otherwise, this is for no reason. So I'm looking to see that the lines are always relative to the thing. It is not like in this. No, the lines aren't, because they need a coordinate system. They need a coordinate system, even though they're being instanced. Weird. So I'm going to store named attribute before the material, although I don't think it matters. I'm going to call this chords, which is my go-to for coordinates, and I'm just going to store the position. And now the only difference here is in the material, instead of using generated coordinates, I use the coordinates coordinate. Okay. So that is something. Now we just got to make sure it's correct on the B, which basically means reducing the scale. Okay. And now how does this do on the lot of them, as the British would say? Yeah. Now the lines are doing the thing. This looks like true hot dog shit. Okay. So these need to have less lines and be shinier almost. Shiny bees. Bit more orange. Bit brighter. Definitely not that rough. I mean, from far away, it ain't bad. But like I said, we need to focus on one bee at a time. As my dad said, one bee at a time. So at some point, it just becomes black. And because we're doing the SDF, it might be easier to just do this using coordinates. So I'm going to separate the coordinates looking at the Y component. And this can transition based on this gradient to just like a dark color. Like that. You can offset it by adding to the gradient like that. We'll call that good enough, even though the legs are dependent on it. You know. Okay. And then low specular. Sheen? Maybe sheen. And then, yeah. We might add eyes, we might not. How is this looking? That's not bad, actually. It's not bad. But now that we're looking at it like this, we can decide what we want to change. So I think first of all, they need some variety. So I'm going to add a noise texture using this coordinate system, and I'm just going to take this bad boy and multiply it by like white and black essentially. And I'm going to make that, oh, what was that? Volume coefficients? Interesting. I'm going to make that higher contrast using a map range, 0.4 to 0.6. Okay. More detail, lower scale. Okay, so this is before and after. Just dirty up them bees. And another thing, and this is just on an instancing level, they're all the exact same size, which I think is actually quite accurate. But I'll go from 0.1, 0.2 to 0.3. So now they're not all the exact. What does it not like about that? Oh. Oh. Oh no, it is already randomized, isn't it? Okay, let's randomize it more. So I'm going to multiply the scale. It's so hard to see the bees. By 0.5 to 1. So now some bees are going to be smaller. Tiny bees. And let's make it kind of ridiculous, right? Nothing's stopping us. More bees. So these are our bees. More of them. Quadruple the bees. And lower their distance. More bees, more problems. How are we doing now? Well, I guess one thing is we got to make sure we bake the simulation, because the motion is dependent on a simulation zone, which it didn't need to be, but it is. So this is where we are. The simulation is going to be on the disk. This should be super fast to bake. By the way, if it's ever like this, where it takes a long time, even though you know it's a simple calculation, make sure you view not all the extra stuff, okay? And now when you bake, even though it's the exact same thing, it's going to blast. So, fun little tip that might save you some time. Okay, so now we got little bees. How are these little bees looking? That's not bad. They could have eyes. That's true. Oh, wait, they don't have fucking wings. What am I talking about? They don't have wings. That was like the key part. Wait a second, they don't have wings. Duh. No wonder it doesn't look real. Okay, let's give it wings. Super low detail wings. Super low detail. So I'm just going to make this shape. Okay? The way I'm going to do that is I'm going to start off with a quad. I'm going to make that quad thin. I'm going to fillet the quad so that it is like this. Nice and rounded. And then I'm just going to squish or skew one side like this so it has more of a shape like that. So I'm going to set position such that I offset on the X depending on the... I'm just blasting through this, okay? We're past the time of explanation. So I'm going to do Y, move it on the X, Yeah. But only the right side. Greater than 0.5. Okay. Again, we're past explanations. The time for explanation's over. So we do something like that. Great. And then I'm going to pinch it on the X. Kind of. And then what I can do to get this to the finish line is I resample, and then I smooth. And that should give it that curvature. Yeah, that's that curvature that I'm known for. Incredible. Okay, this gets filled, and it can be infinitely thin. I don't care. Let's make an attribute just so I can get it all on one material. So I'm going to call it a wing it indeed is a wing. So I just don't want to set more materials than I need to. Let's take this, just move it over there. And then I just need to join these like that. And then put the wing where it's supposed to be, which is somewhere. So where's my wing? There's my wing, 3 times bigger, top view. Let's get our anatomically correct AI generated diagram. Okay, so that's going to be 180 degrees rotating this way, this way. It's about as long as the thing, but not exactly. Okay, then it's coming out of its middle body, whatever that's called. Rotate on the X so it's pointing upwards like that. Okay. I just can't tell if this image is real or not. I'm too disconnected from the bee reality. Okay, so we have that. I'm going to make another transformation because it looks like they have 2 sets of wings or something. Unclear if that's true. Connect that there. This one is going to have a 70% size and is going to be lower. Oh, no. They have 1 set of complicated looking wings. Fuck it. We'll emulate it like this. Okay, we got that. I'm going to join these 2 together so that I can do my age-old flipping trick. Boom. And then, boom. It's a bee. Could I make the wings flutter? Yeah, I could, actually, quite easily. Something like that. And then I'd want to make sure they're not all in unison, so I'd make 2 varieties. But I don't want to. Rotate, rotation. X-axis. What about local? Is that any different? I don't even know. Okay. This can flutter over time. Combine XYZ. Sine wave so that it goes up and down. CG Matter time node, cgmatter.com. Can you tell I'm over it? Has that come to light? And then that sine should be tiny, tiny, tiny. 10 times as weak. Let's look at it like this. Okay. They should be humming, they should be buzzing, and they should be going 10 times faster. Nope. We're talking real buzz, 50 times faster. At a lower scale. So they're barely doing it. They're just buzzing. They're just chilling. They're probably not even using their wings at all, but whatever. Boom. Material. Material. Almost there. Just got to do the wings. How am I going to do the wings, you ask? Well, I'm going to take an attribute. What is that attribute? It's going to be the wings. Is it the wings? Is it the wing? Yeah. And then I just take 2 principled BSDFs and mix them together based on this. So, ba-ba-ba, ba-ba-ba, boom, flip them. This one is transmissive? Oh, why is the thing not copied? Where did I store the wing? Okay. This is the wing. Wait, why is that not working? Oh, it is. Okay, so that's a valuable piece of information. Are they shiny? Are they diffuse? I have no clue. IOR, tinier, so you could almost see through them, right? And just a hit of something, a little hit of, well, they're going to go up and down, so maybe I don't want to mess with it too much. I was going to say a bit of gabber noise. A little alpha. Yeah. Yeah. Do I want to solidify them? I so don't, but should I? Oh, is the issue that they're... I don't even know. Okay, so now they're buzzing. Does that look better or worse in context? Zoom. It's chugging. Zoom. It's chugging. Oh, okay. View. I can't tell. I think it looks better. Okay. So I just got to play with the B material, but we're done. We're done. We'll figure it out on the final render, but I think I got most of the logic done, and I'm happy with that. So, where does that leave us, folks? All 95 of you. Where does that leave us? Well, whatever I do to finish this, which will be cleaning this up, making it make sense, and hopefully making it look good, that is going to be available on cgmatter.com, as I've been preaching. Member site, $5 to get everything, literally everything. 5 years of project files. You heard the guy pimping it out. And all the Nodevember projects, the 11th of which I will upload today. Okay? Additional, and that's the best way to, well, I was going to say it's the best way to fund what I do, which is true, but I hope to give something of value, not just ask for money. Also, there's a free nodes thing over here. I'll get this cooking. I'll make it look better. For the people who know, I always answer one question at the end of these live streams. It could be Blender related, it could be not, but I'm going to wait for like 30 seconds. If you have a question, ask it now. There's no other time. It's now. I'll only select one and we'll move on. One question. What will it be before we end the stream? What will it be? Just one. That's correct. I only answer one question. That way it's not like a Twitch stream, like a just chatting stream. That's not what I'm going for. It's not what I want to make art, make it look good, do it live, and finish Nodevember. Okay, let's do 20 more seconds for questions to come in. And if not, I'll pick the only existing questions. Okay, last chance. Do not miss your chance to blow. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, what are the questions? So the options are just one, thoughts on third-party renders, how do you math, have you considered adding a pay what you want minimum $5 for your website membership fee, not tiered access, but just a way to pay a little extra, Will you make paid tutorials? Will make any more paid tutorials? When did you start learning Blender? Is your IQ 250? You gonna okay? Those are the options. I will be answering. What should it be? What should it be? This is interesting because I guess I don't have much knowledge on it. Thoughts on third-party renderers for Blender. Thoughts on third-party renders. What is he talking about? Well, as you know, current Blender has 3 render engines, kind of. Has Eevee, it has Cycles, and has Workbench, if you count that. There are other renderers you might not know. I think some of them you can download right from the add-ons, so let's see. So by the way, is Cycles still? Cycles render engine's technically an add-on, which you would never disable. One of them I think is called LuxCore. Nope. There's one called LuxCore. There's one called Octane. Those are the ones I know about. Let's see if I can find any of these. Do you have to get it from a website now, or is it not supported? LuxCore Render, I've heard, I don't know much about it, is a unbiased render engine, and it's open source apparently. Unbiased meaning technically more accurate, but also takes more time. So download, version 2.1, supports 4.2 and up to 5.0. Okay. So the honest thing is I haven't played with them. The way that LuxCore ends up working, let's just install it, see what happens. I've been sent on a circular loop. The way it ends up working is I believe it changes your nodes. So I'm just going to start a new file. I'm going to go into the shader editor. And just so you know, I'm out of my depth here. I'm going to install LuxCore. And well, while it waits, you can think of render engines as basically messing with shading and lighting and maybe other things. Okay, what do we got? Edit, preferences, add-ons, enabled. Is LuxCore in here? Blend LuxCore. Okay, use CUDA. Doesn't seem to care. So maybe it's CPU only. Either way. So the moment you add LuxCore render, you're going to notice some differences. Maybe. I thought you were supposed to. Oh, do I need a change to the render engine? Yeah, LuxCore render. So the moment you do that, everything's different. I don't know much about it, but I know the nodes should be different, I believe. But I'm not seeing that. Oh, use LuxCore material nodes. Okay, there we go. So you can see the nodes are very, very different. And I truly have not played with this. Okay, there's our LuxCore. So this is our material, goes in here, goes in here, goes in here. Use the UV map. I don't know what the fuck a sigma is. Oh, there we go. So for example, it's got new texture types like this, apparently. This uses the CPU quite a bit, which if I am coming out laggy, that's why. And I believe it's CPU, oh no, GPU. Is that indeed faster? Let's see, I really don't know anything about this. Material, matte translucent, metal. Interesting. Anyways, so this is a physically based thing. So it's more accurate, but I assume it's not as well documented. Use cycle settings. Oh. So that's what I know about it. So my answer is it's probably cool, but I'm not qualified to answer that question. Okie dokie. So with that, let me get my windows in order. Okay. So with that, that is my answer. Like, long story short, I don't know, but it was cool being able to see that you could just like install it that easily. Last thing, 30 minutes ago, we had a joiner. Oh, it's my wife. It is my wife. Okay, very cool. My wife joined my website. So if you want to be there, go to cgmatter.com. Thank you, everybody, for watching. And I'll get this render cooking eventually. Well, by tomorrow. So